Hey folks, we're on to section 3.2 here, talking about keys in the relational database model. Now, this is going to get a little deep, and that's okay. There's a lot of terms we're going to throw around that really aren't all that important, but there's a couple really key concepts. So the most important one here is the primary key, right? The primary key is the main unique identifier in a given table, for a table, right? And again, that's one or more, right, optional columns or attributes that will uniquely identify that given row, that given instance, that given occurrence of that table. And the goal of the primary key is to do this thing that's called determination. So we're going to say, if you know what the value of this one is, you can determine the other values, right? So if you know the ID, the primary key, if you know your student ID, you can find out, you can determine everything else about student, right? Because that will uniquely identify that given row. If you only know someone's name, right, you can't determine all of the other attributes because that's not a unique identifier, right? There might be that other John Smith. And how do you know which is the right one? If the only thing I've told you is John Smith, you don't know which John Smith I'm talking about. Now again, it's possible, right? You don't have any duplicates, and I would be the only Eric Chinesky in the database, sure. But it doesn't always work like that. So we want to say this is the positive, absolute, unique identifier, and there are no duplicates here at all. There's no chance of a duplicate, and that will uniquely identify, that will determine the rest of it. It is the determination. So that's our primary key. You'll say that relationship, our term for this is a functional dependence. Functional dependence. So all of the other attributes, right, need to depend on that primary key. Your last name, your first name, your phone number, any of the other pieces of information are going to functionally depend on the student ID. Right? Those attributes depend on them. So it is the determinant, right, and the other ones are dependent on the determinant. So that's a bunch of technical terms. Again, the specifics, they're nice to know, but we're not going to use them all that often. And some of these examples of saying, hey, you can determine, or you have functional dependence on more than one attribute is fine, because we can have more than one attribute be our primary key here, but don't say your primary key plus another attribute determines things. I mean, sure, because if you're saying the ID plus a name would determine, say, your phone number, yeah, that's technically correct, because the ID itself will determine the phone number. So a full functional dependency is when everything depends, right? It's fully dependent on just the only piece. So some of those examples we get into are a little silly here. So a composite key is another term here. So composite key, this one is important, right? That's a more than one attribute. Then one attribute makes up a composite key. So if you're not using student ID, if you're doing something crazy, like, hey, here's last name, here's first name, and here's address and phone number, sure, you could do something like that. But the problem is, if you have someone who has a son with like the same name, like a junior, if you only have first name, last name, address, and phone number, and they live at the same house and use a home phone, which I guess is kind of doesn't really happen anymore because everyone has cell phones, but that wouldn't be a good match, right? That would be a bad unique identifier. But you could still call that a composite key because it has more than one attribute. So it's really just if you have multiple attributes, that makes a key here. A super key is a key, whether or not it's a composite key or not, that uniquely identifies. So this one's kind of a silly term. I'm not a big fan of it myself, but it's any key or any unique key. So anything that includes student ID is automatically a super key, right? But sure, why? That's just kind of silly to go through that. So I'm not a big fan of that. Now, one interesting piece here, when you look at dependencies and classifications, the book example is really fun. It says, well, hey, the number of credit hours that you have completed, hours, determines your class, right? Whether or not you're a freshman, sophomore, junior, or senior, right? So if that's the dependency, well, really your class then doesn't depend on the student identifier. Their class depends on the credit hour, and the credit hour depends on the ID. That's sort of an interesting, a way of looking at, well, really it doesn't depend on that. Excuse me. So we need to be careful if we have these sort of transitive dependencies where it's really not necessarily dependent on the ID, it's dependent on something else, right? And at that point, if you can calculate something based on the credit hours, it's kind of silly to store it as an attribute, right? Because, it can cause other problems down the road. If you update the number of credit hours but forget to update the class, you're going to have all sorts of data integrity issues, and that's a bad thing. So of the super keys, right, a subset of super keys is a candidate key. Candidate key. So a candidate key is the minimal key that uniquely identifies, or unique. So using student ID, right, is the minimal identifier. So student ID plus anything else would not be a candidate key because it's not minimal. But the other thing, right, if you had someone's maybe their social security number, that is probably a candidate key because you shouldn't have duplicates in the table. Although I've heard we're running out of social security numbers because they're only 9 digits long, right? And, I think we're starting to reuse them. I would have to double check that again. Right, but if you can only have 9 digits long, that's only 999,990,999. And currently we have what? 300 million or something people? I don't know, we should Google this real quick. This is worth Googling here. Oh, it's open on my other screen here. I'm not even paying attention. Let's Google. So U.S. population. So currently 330 million. Now that's currently alive people, right? But everyone who has been issued a social security number since back when it started here, total number of FSNs issued. Let's see if we can Google that. That looks interesting. 420 million numbers available for assignment. So we have used 579 million of them or so, right? But they're only assigned differently in different states. That's interesting. I didn't know that. So you have a social security area number. The first 3 digits. How cool is that? That's news to me. So anyway, eventually we might run out. So that's, sure, it could be used as a candidate key and it's probably fine, but at some point that might not work very well for us. Okay, so anything that could uniquely identify as a minimal key is considered a candidate key. Okay, and again, matching people is actually really hard. It's a complex problem. Hospitals run into that all the time, trying to make sure they have the right person to find the right medical record. It's a big issue, and unfortunately, the people who are paid to do the data entry, right, your clerks when you get admitted, are not generally highly paid people. And honestly, if you're not paying someone very much, they probably don't care very much about their job. And, it's possible they're going to make typos and not double check and triple check and make sure they're doing all the right things. So if you go to enter someone's social security number and they typo one of the numbers and then it brings up, oh, you must be this other person over here, bad stuff can happen. Right. So, it's a little bit tricky here. So that's why most hospital systems now will give you some sort of medical record number, an MRN that you can use. And they're like, hey, do you have your MRN? Some will even print you off a fancy card and stuff if you're there often enough, like to make sure that they're using the right number. Again, still making sure they don't typo, that sort of thing. But, once you find someone by that lookup, you can say, hey, does the name match? And the odds of you having the same name as someone with a different number, like who typoed it, is probably pretty low. Okay, so when we talk about our tables and we look at having our keys here, we want to make sure that we have integrity. This entity integrity is our keyword here. Entity integrity. I gotta remember to lift the pen up far enough off the screen so I don't get these connections here. So it's making sure that each entry or each row has a unique primary key. Okay, has to have a unique primary key and cannot be null. Now, null is a really special word in database land. If you're taking other programming courses, you might be familiar with the term null. But what null means is not nothing, but it means there's the absence of value, right? So if you're filling out someone's name, right, if you have like first name, and you have middle name, and you have last name, right? Eric Charneski. Sure, you got my info, but if I don't give you my middle name here, you might put in null. And null is a special term to the database saying it's the absence of a value. Null is different from saying, hey, it's just nothing, an empty string, or like blank. It's not blank. It's just not even entered in the data. It's an absence of the value. So this can cause all sorts of problems down the road. Nulls are like the worst thing that can happen in the database. And sometimes we run into them and that's okay. We'll learn how we deal with them. But ideally, we don't put null in. And some of this will come down to your business rules and your policies and procedures and how we go about entering the data. Because, null is really confusing. If I don't have a middle name, is it null? Or is it just like empty? It's just an empty string, just nothing, right? Blank. Blank is different than null, right? Just saying, hey, it's just like a space, right? Just a nothing's here. That's fine. What about if I have a middle name, but you forgot to ask me what it was? Right? Well, are you going to put null in there? Are you going to put empty in there? What if it was like not applicable? So again, probably not for middle name, but something else, like one of our other attributes here might have not applicable. Are you going to put null in there? Or are you going to put an empty value? Right? So nulls can cause all sorts of trouble. Some of the cool things we can do with databases, when we have numeric values, you can get averages, you can get sums right off the bat. And then, well, what do you do with average? If we're looking at, say, GPA, and you're a student who has not taken any classes yet, right? So your GPA, should it be 0 or should it be nothing? There is no value there if you haven't taken any classes yet, right? You registered, but you've not completed anything. If we assume it's 0, then when we do an average and we say, hey, what's the GPA of all of our students here? And we try and figure that out, we'll say, oh, well, this person has a 0, right? This person has a 3.7, this person has a 4, this person has a 2.1, whatever. That 0 there is going to tank the average. So again, maybe null is appropriate. Like you don't actually have one. You don't have that value. It's possible. And again, there's some things to look at as we get there. But nulls can cause all sorts of trouble. So it's really good to have good policies and procedures and business rules around what we do with the data if we don't know the value, right? Or if it's just not applicable or whatever that case might be here. So you got to be careful. Nulls are really funky. All right, and then another key that we want to look at is called a foreign key. Foreign key. And a foreign key means you're a key from another table. Other table. Right, so when we looked at, hey, what was that relationship between a salesperson and a customer? Right, so then our customer table, we said, hey, one of these attributes here, right, was the salesperson person ID. So the salesperson ID here is a foreign key because it will relate to, over in our sales table, the ID field of salesperson. Right? So the foreign key says, hey, I am going to reference something in another table. And again, we're going to use the key, we're going to reference the primary key in another table. So if it's a composite key, if it's more than one value, we're going to have more than one attribute as the foreign key. The foreign key can be a multi-attribute field as well, if the primary key in another table is. Sure, there's nothing wrong with that. That's fine. And one of the important jobs in a relational database management system is to ensure this thing called referential integrity. That's an R, right? Referential integrity. Okay, referential integrity means that anytime you have a reference, it exists. So if I put salesperson number 3 here, the database will only let that happen if there is a salesperson number 3 to reference with a foreign key. If I put in salesperson number 27 and it doesn't exist, the database is going to puke on it. Its job is to ensure we have referential integrity, saying, yes, I reference a valid value in that other table. And that's really important because if your field is supposed to be a foreign key, you need to be able to go find where it relates. You need to go find all the other information because remember, this key here is the determinant for all of these other values. So if I want to say, hey, what's the salesperson's name who this customer should talk with? Their ID, salesperson ID, is the determinant. It will determine all of those other attributes because it's the unique identifier. And if you don't have that column, or if you don't have that value in the other table, you can't look any of that stuff up. And that's garbage, right? It's not going to work. So the foreign keys make sure that we have referential, or we ensure that all foreign keys have referential integrity. That's the database management system's job. Now, it might be possible, and again, depends on how you define your columns here, that null might be okay. So if null makes sense, like, hey, we have a brand new customer, they haven't been assigned a salesperson. Should we have null there and say there is no salesperson assigned? Or maybe we make a salesperson number like 999 who is dummy, right? And not a real salesperson. And again, that comes down to our business process and our business rules and how we want to define that for our business. Right? Is null appropriate, or should we map it to and reference this dummy salesperson that doesn't actually exist? They're just a placeholder. Up to the business rules. That we can design around either one of those ways, and that's okay. Right, and the last key we're going to talk about is a secondary key. Secondary keys are important for lookups and for speed. So when you call enrollment services or somebody here as a student, and they say, hey, what's your student ID number? You probably don't have that memorized. But they'll probably say, okay, what's your last name, what's your first name, and maybe one other piece of information to make sure we have the right you, right? Maybe what's your address, right? The last name, first name, and address is probably going to get really close to the right you. And if it's not you, maybe it's your brother or your sister or your mom or your dad, or probably someone who you live with because they have the same address. So we can get really close from there. So a secondary key is one that we use just for lookup purposes. Okay, so again, we'll get more into that later, but just keep that in your pocket. So secondary key is also a concept. So a lot of different terms that we use when we talk about keys. Right? We have super keys. That is the attribute or combination of attributes that identifies our table. We have the candidate key, which is the minimal, the smallest possible uniquely identifiable key here. We have the primary key, that's our main identifier. We have the foreign key, which references another primary key in a different table, and then those secondary keys that we just use for lookup purposes. So lots going on with keys, and we'll get into how they fit into the rest of the relational database model as we go.